In this brief tutorial, I'm going to introduce commands which are used to manipulate and edit audio file by using the idea of Discrete Fourier Transform or DFT. Basically, DFT takes the continuous audio file function and transfer it into n number of samples. The main factor in quality of sounds are the number of sampling per second, which is known as sampling frequency. Let's call the audio file. I already saved my audio file in MATLAB file. We're gonna use waveread function to call them. The waveread function basically samples the audio file into discrete format. X is sample data and f of s is sampling rate per second. Now let's find out the value of f of s, which for CD quality, the sampling rate is almost 44,100 samples per second. We can find out the total number of samples by using length function. Now, I'm gonna plot the graph of the audio to make it more clear. I already saved my codes in my M file, so I'm gonna call them and show them to you. The first graph, as you can see, is gonna show how long the sound is in time domain. And the second graph, I just zoom and graph it for the first 50 samples by taking DFT of x and plot its absolute Fourier transfer value as a stem plot. To find the specific bin frequency, we can use the following formula. For example, I choose bin number 26 and I found out the frequency of bin number 26, which is equal to 3.60 Hz. Now let's move on and begin editing the sounds. Here are two sounds that we have. We can play the audio by using the sounds command. So let's hear the sounds that I have. The first one is
the oral presentation for ECE 209.
And the second one is
this presentation is done by Fourier.
By putting x and f of s, we mean to play sound wave of x at normal rate. Now, if I change it to something like 80,000, it would play a lot faster because of the time it takes to play the same sample is shorter. Let's try it. My final goal is to edit and combine these two sounds together in a single audio file. The final sound we play, the oral presentation for ECE 309, is done by Fourier. From first track, we want the sample in time period of 2 seconds to 5.5 seconds to be extracted. The code is this, so let's hear the edited sound together.
The oral presentation for ECE 209.
We're gonna use same code to extract the samples that create a new sound saying is done by Fourier. So let's hear the second edited sound together.
It's done by Fourier.
The final step is to put this sound together. In order to do this, we are going to use matrix properties by creating a new sound vector called editor that contains two edited sound vectors. However, before doing that, we have to make sure that both edited sound vectors are either column or row vector. So we're gonna use size function. As we can see, they are both column, so we can create the new vector and we're gonna call it editor. And now let's hear the final sound that we have.
The oral presentation for ECE 209 is done by Fourier.
In summary, this is what we did. Here are two original sounds. The first one was
the oral presentation for ECE 209.
And the second one was
this presentation is done by Fourier.
And this is the final sound we create by knowing the idea of the sample.
The oral presentation for ECE 209 is done by Fourier.
Thank you for watching sound sampling tutorial.